Following on from the previous two videos, our aim was to derive these identities here, and the way we did that was to construct a circle of radius 1, and then we noticed that well, not so much notice, we know that this length here is exactly the same length as this length here. Okay, and by using Pythagoras, PR squared, well, if we construct a right angle triangle here, so this is our right angle triangle here, you see PR squared equals this length squared, and then plus this length squared is basically Pythagoras. So PR squared is given by this whole thing here, and that was in the first video here. That was in the first video, and then blah blah blah. So PR squared is given by this, okay. And then in the second video, it was QS squared. So now we've got to consider this triangle here. So we've got to consider this triangle here. So our triangle is this. So from Q to S is this, and then from Q straight down it would be this, and then straight across here. So we've got a thin triangle looking like this here. So this point here is your Q here. This here is S, and this is your right angle triangle here. And the thing is QS squared, which is this area here. Okay, this square here is equal to this height here squared. Okay, which is this bit here. Okay, which is this bit here, and then don't forget we've got to get the base. We've got to square the base here. So QS squared is given by this. Okay, so this was the end of video 2. So now we've got squared here, so we've got to multiply out these brackets here, these squared brackets. So it's like you doing this. It's like you having this here. Okay, so squaring this would be get it and times by itself. So it would be you doing this. Hang on, bear with me. You'll understand in a minute. It's like you doing this here. So this times this here would be so looking at this here. This times by itself. So basically, we are trying to square this bit here. Okay, so when you square that bit there, it would be this times this, which is this thing times by itself. And then this times this, and then this times this will give you two lots of. So basically, when you square this here, it will give you this. Okay, and then later on you get this square times it by itself. It will give you cos squared minus beta. Right? Cos squared minus beta. Okay, so this squared here would give you this. Okay, now multiply out the brackets here would give you this. Okay, so this part here is this block here, and this block here is this block here. So multiply out the brackets. Okay, and then notice, remember, I asked you to ingrain this inside your mind here. 1 squared, or 1 equals cos squared theta plus sine squared theta. So yeah, I asked you to ingrain this inside your mind. You have to memorize this. So hang on, start again. So this bit here, when you multiply this bit out, it will give you this. Multiply this out, it will give you this. So basically, you've got this block plus this block here. Now the thing is, when you combine these two, look at this, combining these two, exactly the same angle. Exactly the same angle, and you've got cos squared and then you've got sine squared. So remember, 1 equals cos squared theta plus sine squared theta. Whenever theta, whenever these two whenever this angle is the same as this angle here, and you blah blah blah, this here equals 1. So basically, if you combine these two, that would give you 1. That would give you this one here. Now combine these two. So here you've got cos squared, exactly the same angle, sine squared, exactly the same angle here. So combining these two will give you this one here. Now, yeah, so this remains the same. Let's just carry that down. And this here remains the same. Let's just carry it down. The important part is that if you combine these two, that will give you 1. Combine these two, so that will give you this one here. Okay, so this whole thing here becomes this. Okay, and now what? Hang on, let me think. Single number merge these two together. That will give you a 2. Okay, so everything else remains the same. So from here we would get to here. Okay, and then let me think. Oh yeah, and then hang on. Hang on, let me think. Sorry. Combine these two. I'm going back a few steps here. Will give you 1. Combine these two here. Will give you this one here. So merge these two together to give you this 2. Okay. So now, hang on. So now that will take us to here. Now, if you look at cos minus beta. Now, now look at this graph here. When you draw the graph of cos of x, it will look like this. You see, the graph cos of x is an even function. So that means when you cos minus, let's say if you it's an even function. So cos minus beta is the same as you doing cos positive beta, because it's symmetrical along the y-axis. It's an even function. So it's like me giving you this here. Y equals x squared. So y equals x squared. So hang on. So hang on. Let's just say f of x equals x squared. Now, rather than finding out f of, let's say, minus 3, rather than doing minus 3 squared, I could, if I wanted to, because this is an even function, I could just do f of positive 3. It would be the same thing. Minus 3, and then rather than doing minus 3, I can just ignore the minus because it's an even function. So looking at this cos function here, this is an even function. So when you've got an even function, if you cos minus an angle, you can't just ignore the minus. You can just do cos beta. It looks neater and it's a lot tidier. So because cos of x is an even function, so rather than finding out cos of, let's say, minus 32, you can just, it would be the same thing. Cos minus 32, I don't know, maybe around here. You could just ignore it and just do cos 32. You're allowed to do that because you know it's an even function. Okay, so because cos of x is an even function, we can just ignore this minus. It will be the same thing. This thing here will be exactly the same thing as this. Okay, so this here will then become this here. So all that we've done is that this here, we know that these two boxes, they're the same. Okay, so from here we are now here. Okay, so now consider sine minus beta. Now sine minus beta, if you look at the sine graph, hang on. So now if you look at the sine graph here, the sine graph looks like this. You start at 0 and then it goes up and then down here. Now the sine graph, it's an odd function. So you doing is an odd function. So you doing a minus version. So you finding out minus sine minus beta. That's the same as you finding out beta and then sticking a minus in front of it. It's like you having wait there, f of x. It's like you having f of x equals x to the power of 3. So rather than doing f of minus 3, f of minus 3, you could just do f of 3 and then work out the whole answer and then sticking a minus in front of it. That's allowed because you know it's an odd function. So rather than you finding out this point here, let's say minus 3 here, you can just do f of positive 3, and then sticking a minus would take you to here. Well, anyway, sine hang on. So sine, because sine is an odd function, you doing sine of minus beta, that's the same as you just working out sine beta and then sticking a minus in front of it. That is the same thing because it's an odd function. So so this bit here, you can imagine it as this. Work out sine beta. So we are currently here. Okay, and now this bit here, because it's an odd function, you can imagine it as this box here. So this 2 here is this, and then this sine theta here, sine alpha here, is given by this, and then this thing here, you can imagine this square, this block here is this block here, because just work out sine of beta as normal, and then stick a minus in front of it. So now so visualize this thing here as this block here. Okay, so you've got this multiply with this, multiply with this. You've got a minus here, so that would then hang on, you've got a minus here, so that's like a minus 1. So merge a minus 1 with this 2 here, so it will become a positive 2. Okay, so this thing here will become a positive 2. Hang on, bear with me. Yeah. So this hang on. So this here is like a minus 1 here. Merge this with this, so that will then become a positive 2. So now the whole thing here becomes a lot neater. We don't need to worry about this minus beta, but now it's positive beta. So this will then become this. Okay. Hang on. So QS squared is given by this. Okay. I will continue in the next video. Okay.